Now, students, we have to go through the energy flow into the ecosystem. Now, you see, except deep sea hydrothermal vent, and all over the earth, the source of energy is the only source is the sunlight. You will think that what is the source of deep sea hydrothermal vent? તમે યાદ કરો આગલા ચેપ્ટરમાં આપણે આવી ગયું કે chemotropous bacteria હોય એ શું કરે? That is converted that particular organic substance into inorganic substance, and as a result of this they will utilize the energy of it, and ultimately their energy is not, they are not aware with the sunlight. Okay, so that is why in the first sentence of it is mentioned that except deep sea hydrothermal ecosystem, sun is the only source of energy into the whole ecosystem of the earth. Now, of the incident solar radiations, less than 50% of its photosynthetically active radiation. Suppose total solar energy, out of them, photosynthetically active radiations, like 400 to 700 nanometer wavelength that we have already discussed in our photosynthesis chapter. And that is PER, photosynthetically active radiation is 50%. But that completely this 50% is not absorbed by the plants during the photosynthesis. Actually, they have utilized only out of this 50%, only 2 to 10% solar energy will be captured by the plants from this PER, photosynthetically active radiations, right? एक तो total જેટલી solar energy હતી એમાંથી photosynthetically active radiations કેટલું છે 50%, and from that particular 50% of the energy, particularly plant is captured only 2 to 10%. Okay, now this energy sustains the entire living world. They are 2 to 10% captured plant for the photosynthesis. That's where they sustain the entire living mass particularly. Now, as far as if we are talking about unidirectional flow of the energy is concerned, particularly, you know that the producers, particularly plant, will be act as a producers, and they will produce the energy. Now, that energy is flowing unidirectionally. How? That particular plants is eaten by, we can say, herbivores, and then into the food chain. Herbivores, then after carnivores, the unidirectional flow will be there. And that can be explained through the law of thermodynamics, we can say. Okay? Why it's unidirectional? That we can explain through the law of thermodynamics, and that is first law of thermodynamics and second law of thermodynamics. You remember that particular law of thermodynamics. What is the first law of thermodynamics? The first law of thermodynamics is that energy neither can produce nor can be destroyed. Energy neither can be produced nor can be completely destroyed. But it should be converted from its one form to the another form. Isn't it? That is the first law of thermodynamics. Now, as far as second law of thermodynamics is concerned, when the form of energy which is converted from the one form to the another form, in that case what happens? Little bit amount of energy will be wasted in the form of heat that cannot be utilized. So that is why the constant supply of energy is required for any of the ecosystems. That is, you can say, second law of thermodynamics. Okay, so it is not given in your text actually, but that is first and second law of thermodynamics is there. And on the basis of that, the constant energy supplies to the molecules of the required and contract the universal tendency of this increasing disorderliness. That means what? That means they are talking about that constant energy supply is required as far as sunlight is concerned. Otherwise, disorderliness means imbalance of the energy. Suppose constant energy છે એ ઘટતી જાય, બરાબર, તો શું થાય? તો કે એની સામે એને એમ કે કરવા માટે થઈ અને એને કોન્સ્ટન્ટ, સપોઝ એને કોન્સ્ટન્ટ સોલાર એનર્જી મળવી જોઈએ એવું કહે છે કે જો કોન્સ્ટન્ટ સોલાર એનર્જી ના મળે તો શું થાય કે જો સોર્સ છે એ કમ્પ્લીટ ઝીરો થઈ જાય તો ગ્રેજ્યુઅલી the loss of energy will be ultimately extends to zero or imbalance into the atmosphere. Okay. Now, if we are talking about producers is concerned, what is producers? Generally, green plants are the producers. Okay, because they produce the food through the photosynthesis, and that is they will utilize the solar energy. And particularly, green plants will be act as a producers. But if we are talking about terrestrial ecosystem is concerned, in the terrestrial ecosystem, herbaceous as well as woody plants is available as a producers. You can see that. And in the aquatic ecosystem, what happens? Phytoplanktons and other higher plants will be available as a producers. Now, if we are talking about the food chain is concerned, some of the organisms they will consume whatever the food which is synthesized by the producers or we can say plants, and the organisms which is feed upon the producers or we can say plants, that is called what? Consumers, because of they consume the food which is synthesized by the producers. That is why it is called a consumers. Now, if the particular organism is feed on the plant only, that is called what? Herbivores. That is called herbivores. Now, if we are talking about the organisms which are consumed or they are feed upon the herbivores, or we can say primary consumer, we can say, right? It is called what? It is called carnivorous, or we can say secondary consumer. Now, some of the organisms which are fed upon that particular primary carnivorous, and that is called what? Top carnivorous, or secondary carnivorous, or third level of consumer. Okay? So, that is kind of a food chain we can say, which can be accessed into the atmosphere. Like this kind of food chain is deciduous or classified into two types. Grazing food chain, in short GFC, and another one is detritus food chain, it is called a DFC. Now what is grazing food chain? You can see that particularly it is mentioned producers, then herbivores, then primary carnivores, then secondary carnivores. Now what is producer exactly? Producers are the plants. Suppose હું તમને એક એક્ઝામ્પલ આપું કે એક પર્ટિક્યુલર ગ્રાસલેન્ડ ઇકોસિસ્ટમ છે એની અંદર grass is the producers. Now grasshopper we can say. Grasshopper is herbivores. Ready? Then some of the frog particularly which are taken this insects like grasshopper as a food. That is why the frog is primary carnivores. And snake is concerned, which is feed upon the frog. And that is why it is called what? Secondary carnivores. So after every food chain જોઈએ તો grass, grasshopper, frog, then even snake, and even some birds like hawk. This hawk is concerned, they feed upon that, even frog as well as snake. So they are not carnivores. So that is the grazing food chain, which is initiated with producers and complete like this with top carnivores. But if you are looking at detritus food chain is concerned, you know that it starts with decomposers, because decomposers is decompose the dead material, detritus material. You know that the decomposition process. right? Decomposes is converted that complex organic matter into the simple inorganic matter. Now that simple inorganic matter is utilized by producers, and then these producers is provide the nutrition to the herbivores and then carnivores like primary, secondary, and top carnivores. So that is the detritus food chain, DFC. Okay, and that is where you can say GFC and DFC in short. Detritus food chain is DFC and GFC is grazing food chain. Okay, and particularly if we are talking about this detritus organism is concerned, it is called as cephalopods because of the obtained energy through the decomposition. That is called as cephalopods. Okay. Now, in aquatic ecosystem is concerned, the major conduct of the energy flow is GFC, grazing food chain, because in the aquatic ecosystem there is no decomposers is there, and that is all. But in terrestrial ecosystem, much larger energy flow occurs through DFC, detritus food chain, because there is a decomposition is there, and as a result of this, it is happening. Okay. Then after we can say, particularly, detritus food chain may be connected with the grazing food chain at some levels. That is why some organisms of DFC are prey to the GFC. And in natural ecosystems, some animals like cockroach, then crow, they are omnivorous. Omnivorous means they can utilize plants as well as animals both. So that is why it is called omnivorous. Okay, and that is why this kind of food chain is from what? It is food web. It is not a food chain, but it is food web is concerned. Okay, then after particularly, if we are talking about the relation between one organism to the another organism is concerned, organisms occupy the place of natural surrounding or a community according to their feeding relationship on their organisms. Okay, and this is based on the source of their nutrition or the food. Organisms occupy a specific place into the food chain, which is known as trophic level. And the food can nutrition to source chain, and the organisms share particular specific place share any food chain occupied correction. That is called a trophic level. And you know this particular is indicated the trophic level. Like primary producers is concerned, it's a first trophic level. Plants, it's a first trophic level. Okay, the trophic level is first. Now, primary producers provide the energy to the primary consumers. The consumer level is primary, but if we are talking about trophic level is concerned, these are herbivores. Like you see, if you are talking about grass and trees, these are producers. And if you are talking about grasshopper, zooplanktons and cow is concerned, it is, we can say, herbivores, secondary trophic level. Now, secondary consumer, they are carnivores, but it's third trophic level. And the example is given in your text is the birds, fishes, and wolf. And tertiary consumer, fourth trophic level. We can say top carnivores like human and lion. Okay. And other say producers, primary consumer, secondary consumer, and tertiary consumer. Okay. And here first trophic level, second trophic level, third trophic level, and fourth trophic level. And the examples પર આપણે પેજ નંબર 246 ઉપર આ ડાયાગ્રામ છે આપેલો છે ઓકે એટલે બહુ ઇઝીલી તમે એ કમ્પ્લીટ કરી શકશો. Now particularly it is important that the amount of energy is decreased at successive trophic level, and the organisms digest is converted to the detritus and the dead biomass that serves as an energy source for the decomposers. Now, which trophic level depends upon the lower trophic level of that energy demands? That means what? તમે જુઓ કે સૌથી વધારે એનર્જી ક્યાં હોય? Primary producers, because of they will convert that photosynthetically active radiation into the biomass, we can say, or organic matter. Right? They will produce the energy. They are producers. But then after what happens? When through the food chain, through the successive trophic level, when the one organism to the next organism, the energy flow will be taken place. Some amount of the energy can be utilized into the respiration process. And that is why in successive trophic level, the energy will be decreased. The સૌથી વધારે એનર્જી ક્યાં છે? પ્રાઇમરી પ્રોડ્યુસર્સ માં. એનાથી ઓછી પ્રાઇમરી કન્ઝ્યુમર્સ માં. એટલે પછી થર્ડ ટ્રોપિક લેવલ અને ફોર્થ ટ્રોપિક લેવલ. આવી રીતે એની એનર્જી ફ્લો છે એ ધીરે 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 કમ્પ્લીટ ઓછો થતો જશે. ઓકે, ધેટ ઇઝ ધ we can say at each trophic level it is decreased. Now, standing crop. Now, each trophic level, certain mass of living matter at a particular time is called for standing crop. બરાબર કે each and every જે trophic level છે ત્યાં certain mass of living material particularly like biomass, okay, at a particular time is called a standing crop. Particularly definition તમારે ખાસ underline કરવા જેવી છે. બરાબર? And you can express themselves as a driving, or we can say express as a their biomass. Particularly, now the number of trophic level of grazing food chain is restricted to transfer of energy flow 10%, and though only 10% of the energy is transferred to each trophic level from the lower trophic level. Suppose energy point producers પર જેટલી એનર્જી હોય એમાંથી only 10% જ એના next trophic level માં જાય. અહીંયા 100% હોય એમાંથી 10% જ જાય. અહીંયા 10% છે તો અહીંયા 1% જાય. એવી રીતે gradually next trophic level માં એની એનર્જી કેટલી લો થાય તો આગલા નીચલા trophic level કરતા ઉપરના trophic level માં કેટલી હોય 10% જ હોય એનર્જી. And particularly it's possible to have some levels producers, herbivores, primary and secondary carnivores, the grazing food chain. We can prepare the pyramids. As far as pyramid is concerned, it's an ecological pyramids. You can see the pyramids is concerned. There is three kind of pyramid is there. As far as this trophic relationship is concerned, okay, you can see the diagram which is given on the page number 248. Okay, on the basis of that, you can see that at the bottom it is always there is a producers, primary producers, and then after on the upper side it's second trophic level, it is herbivorous, and then after we can say, or we can say primary consumers, and then secondary consumers and tertiary consumers. Now there is a pyramid, three kinds of pyramid is there. Number of pyramids of numbers, pyramid of biomass, and pyramid of energy is concerned. As far as pyramid of number is concerned, see, highest number is producers. You can see the in your textbook particularly, the number has been given that 58,42,000 is the number at the producer level. Now the second 7,08,000 is the number at primary consumer level. Then secondary consumer level it is 3,44,000. See, our textbook પર number આપ્યા છે એટલા માટે આપણે યાદ રાખવાના છે. And tertiary consumer 3. એવું તમે biomass નો biomass should be expressed in the dry weight or kg per square meter. Like you see, primary producer is 809 kg is the dry weight. Then after primary consumer is concerned 37, then secondary consumer is 11 and tertiary consumer is 1.5. Now you see in the 14.4c is concerned. Is inverted pyramids of biomass, small tending crop of phytoplankton support a large tending crop of zooplankton. You see, તમે ઓસન હોય એ ઓસનમાં એનો બાયોમાસ પિરામિડ જુઓ તો આવો આવે કે એની અંદર પ્રાઇમરી પ્રોડ્યુસર્સ છે 4 છે અને પ્રાઇમરી કન્ઝ્યુમર્સ is 21 biomass. Because of why? The phytoplanktons check, their lifespan is very much short. See, answer is not given in your text then why it's inverted. But I can tell you that the primary producers is phytoplanktons. Even its size is very small. Even they cannot store the biomass in a large amount. But if we are talking about the zooplanktons or fishes is concerned, we can say these species are primary consumers. And their size is much larger than the phytoplanktons, and that is why they can store a large amount of the energy in their body or the biomass in their body. And that is why we can say such kind of inverted pyramid is seen in it. Okay? Then after we can say energy pyramid, which is given on your textbook, and that is page number 249. You can see that at the primary producer level, that is 10,000 joule, and thereafter at the second tropic level is 1,000 joule, and third tropic level it is 100 joule, and the top level is only 10 joule. You can see that only 10% of the energy is transferred to the next tropic level, right? Only 10% energy is transferred to the next tropic level, and that is why we can say the pyramids of generally what happens in most of the ecosystems, the pyramids of mass as well as biomass is generally upright, but in some cases it may be inverted. But the energy pyramid will be always upright. Okay, we can say the energy pyramid is always upright. There is some controversy which is discussed about this. That any calculation of energy content, biomass, mass has included all the organisms into the tropic level. No generalization we will sure if we will take only a few individuals at the tropic level into the accounts. Also given many occupy more than one tropic level simultaneously. Sometimes what happens? Some of the organisms they will occupy more than one tropic level in that. Suppose sparrow sometimes is grazing the grains, or sometimes they will eating the insects also. So they will exercise herbivores as well as carnivores. Okay, and in that case, in the same ecosystem, the species can be occupied more than one tropic levels. Okay, and particularly fruit, bees, and secondary consumers like sparrow will be eating all of this. And that is why in most of the ecosystems, pyramids of number, pyramids of energy and pyramid of biomass is always upright. But our producers are more than the numbers, and biomass, then the herbivores, and herbivores are the numbers, and the biomass are more than the carnivores. Okay. Then after there is some exception is there. To this generalization, you will count that the number of insects. Suppose an example I put it. There is a tree, just one tree is there. Now, the tree is just a one. Now there is a number of, we can say, tree number is just one. Now there is a herbivorous insects are available on it. There is large number of insects are available. These are primary consumer, and then some insectivore birds are available on it. So such kind of pyramids is there. It's a primary producers, primary consumers, and secondary consumers. Okay, such kind of pyramids can be there. So in that case, it is not always upright. You cannot generalize that particular. Now, pyramid of biomass in sea is also generally inverted because of the biomass of fishes exceeds of the phytoplankton. આપણે હમણાં ડિસ્કસ કર્યું 14 for forward C. Okay, and that is because of this reason. Now, pyramid of energy is always upright. This can never be inverted. That's you have to remember. Because whatever the energy is flow from a particular topic level to the next topic level, it will release in the form of heat. So that is why the amount of energy will be gradually decreased, which cannot be obtained by any topic level. And that is why we can say it is actually always upright. That is given in your page number 249. However, the certain limitations for the ecological pyramid is concerned, such as it does not take any account of same species belongs to the two or more trophic level, and it assumes the simple food chain, something that almost never existed, and in the food web. So that is the completion of the energy flow. Now, in the next, we can say lecture, we will go to the ecological cessation. It's a new topic for you. Okay?